Hi guys, welcome to Lesson 7 SN, Part A, Scientific Notation. Our objective for today is that I can write numbers in scientific notation and standard notation. Our essential understanding, scientific notation can be used to represent very large or very small numbers in a more manageable way. So, what is scientific notation? It is a number that is written in the following form. A times 10 to the b power, where a is greater than or equal to 1 and less than 10. So, when converting from scientific notation to standard notation, which is just written without exponents, the exponent tells you how many times you need to move the decimal point. If the exponent is positive, we're moving the decimal point to the right. If the exponent is negative, we're moving the decimal point to the left. Now, think about what we did with our exponent rules previously. If we're multiplying by 10 to the fifth, that means we are multiplying 3.4 times 10 5 times. So, we start off and write our 3.4. And we need to move our decimal point 5 places to the right. Well, I've run out of numbers. We're still going to do our hops. 2, 3, 4, 5. So our new decimal point goes right there. But what we need to do is add in a couple zeros for each of those gaps that we jumped over. So 3.4 times 10 to the fifth is 340,000. Okay. Now, when we've got letter B, 8.8 times 10 to the negative second, that means we are moving our decimal point to the left. Now, we can think of this. If we were to rewrite this as a positive exponent, it'd be 8.8 times, or divided by 10 to the second power. That's why we're getting smaller. We're dividing by factors of 10. So we're going to divide 8.8 times by 10 twice. So we start off with our number, 8.8, and we start where our decimal point was originally, and we are going to move 2 steps to the left. 1, 2. So that means we're going to have to write in 1 extra 0 to cover that space. All right, so 8.8 times 10 to the negative second power is 0.088. This is where our new decimal point is. Okay. Letter C, we've got 4.56 times 10 to the third. So we start off by writing the numbers that we have already. And it's 10 to the third, so we're going to move to the right. We're going to go 1, 2, 3 steps. So we put 1 extra 0 in there. 4,560 is 4.56 times 10 to the third. Okay. Now we've got letter D, 1.02 times 10 to the negative sixth. Well, let's start off. We've got 102. And we want to move to the left, because it's negative, 6 places. So we go 1, 2, 3, 4, 5, 6. Put in your new decimal point there, and you need to fill in the blanks, a 0 for each place that we moved over. Okay? So 0.0000102 is 1.02 times 10 to the negative sixth. All right. I want you guys to try letters E through I on your own, and I will go over them. So 7.345 times 10 to the sixth, we write this as 7,345, and we're moving to the right 6 decimal places. So we go 1, 2, 3, 4, 5, 6. The new decimal point is right there. We can count our hops to verify. 1, 2, 3, 4, 5, 6. All right. Number or letter F, 5 times 10 to the negative fourth. So we start with 5, and we're moving to the left because it's to the negative fourth. So we go 1, 2, 3, 4 decimal places. 1, 2, 3, 4. Okay, so that's 0.005. Letter G, 2.99 times 10 to the negative third. 299. Negative third, we're moving the decimal point 3 to the left. So I need to put 2 zeros out front. Here's a little hint. When you are moving the decimal point to the left and the number is already in scientific notation, you're going to add 1 less than this number of zeros. So we're moving it to the left 3. Our first step is always going to be over that first digit. So then we're going to have however many more zeros there are. All right, so our first step out of 3 was over the 2, so then we had to add in 2 zeros. Up here, our first step was past the 5, then we had 3 more steps, 3 more zeros. All right, so just a little trick. All right, now letter H, 6.1 times 10 to the 9th. So we have 6, 1. We've moved 1 decimal place. 2, 3, 4, 5, 6, 7, 8, 9. And if you want, you can put commas in there, and you can see that this is 6,100,000,000. Okay. Letter I, 7.9 times 10 to the 4th. We have 7 and 9, and we're moving it to the right 4 times. So 1, 2, 3, 4 places. Okay. Make sure you clearly identify where your decimal point is in the new number. All right. Problem number 2. Going from standard notation to scientific notation. When converting from standard to scientific, we need to move the decimal point to the right of the first non-zero digit and count how many places that it moved. So we want to put our decimal point to the right of the first non-zero digit. So that's going to be right there. So how many times do I need to move my decimal point to get it from where it started to there? It's going to be 1, 2, 3, 4, 5, 6, 7. So we have 3.05 times 10 to the 7th. Now it's going to be a positive 7 because this is a number that is greater than 1. If it's a decimal, it'll be negative, but if it's a large number, it'll be positive. All right. Letter B. We put our decimal place to the right of the first non-zero digit, so that'll be right there. So we start off, we write 7.81 times 10. Well, how many hops do we need to make? 1, 2, 3, 4. 10 to the negative fourth. Letter C. 622 times 10 to the 6th. Well, I decided to be a little tricky here, because problems are not always presented to you already in scientific notation, so you have to convert them. So we put our decimal point to the right of the first non-zero digit, 6.22, and that is going to be times 10 to the 2nd power times 10 to the 6th power. Well, it looks to me like I have the same base, so I can add those exponents together. So it's going to be 6.22 times 10 to the 8th power. Okay. So remember, if a number is going to be in scientific notation, that term in front of the times the power needs to be between 1 and 10. Okay. Let's take a look at letter D. we have 0.000002. So we're going to start, we're going to put our decimal point to the right of the first non-zero digit. And I need to move the decimal point 1, 2, 3, 4, 5, 6, 7 places. So that's going to be 2 times 10 to the negative 7th. Okay. I want you guys to try E through I on your own, and I will go over them. So letter E, we put the decimal point right there between the 5 and 7, to the right of the first non-zero digit. And so we have 5.73 times 10 to the 1, 2, 3, 4th power. Okay. Letter F, we put the decimal point after the 9, so it's 9.05 times 10 to the 1, 2, 3, 4th power to the negative 4th power, because our number is a decimal. All right. Letter G, 0.001 times 10 to the 12th power. Well, let's convert this. So we put our decimal point there. So it's 1 times 10 to the 1, 2, 3, negative 3rd power, times 10 to the 12th power. Well, we can combine that. 10 to the negative 3rd, 10 to the 12th, same base. Add our exponents. 12 plus negative 3 is 10 to the 9th. Letter H. We put our decimal point to the right of the first non-zero digit. 1.2 times 10 to the 5th power. Letter I. We put the decimal point next to the 8. So we have 8.1 times 10 to the negative 3rd times 10 to the negative 3rd. Same base, add the exponents, 8.1 times 10 to the negative 6th power. Okay. Now moving down to problem 3, these are real-world applications of scientific notation, the kinds of things that we would use scientific notation to represent. Like I said, they're going to be very large or very small numbers. So letter A, the unit of measure for counting molecules is a mole. 1 mole of a substance is the amount that contains about 602 followed by 3, 6, 9, 12, 15, 18, 21 zeros. We want to write this number in scientific notation. So I put my decimal point after the first non-zero digit. So we have 6.02 times 10 to the, well, let's see, how many decimal points do I need? We've got 3, 6, 9, 12, 15, 18, 21, 22, 23. So 6.02 times 10 to the 23rd molecules. This is known as Avogadro's number. When you guys take chemistry, that will be a very important number for you, and you will be using it a lot. 6.02 times 10 to the 23rd. So 1023, my birthday, is also known as Mole Day among nerdy science people. All right. Letter B, the mass of a proton is point, whole bunch of zeros, 167265 kilograms. We want to write this number in scientific notation. So, again, we start with just writing our initial number, 1.67265 times 10 to the, well, let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 1.67265 times 10 to the negative 27th kilograms. Okay, letter C, we're going to write the number in standard notation. The center of the moon is 2.389 times 10 to the 5th miles away from the center of the Earth. So we start off 2.389. We are moving it to the right 5 places. So 1, 2, 3, 4, 5. So the moon is 238,900 miles from the center of the Earth. Center of the moon to the center of the Earth. Okay. Last question, letter D. The usual growth rate of a human hair is 3.3 times 10 to the negative 4th meters per day. Write this number in standard notation. All right, so we've got 3.3 times 10 to the negative 4th. So we're moving it to the left 4 places. 1, 2, 3, and the original was 4. So we have 0.00033 meters per day. So that's how long or how much your hair grows on average in a day. All right. All right. Now, that's the end of the notes for today. Make sure you rate your level of understanding, 1 through 4. And make sure you write down any questions you may have come up with during this lesson. And write down your summary of how to convert numbers into and out of scientific notation in your own words. All right. Have a great night, and I will see you in class.